4 years ago, I recorded a video showing how I leveled a small above ground pool on my patio using some cleverly arranged pieces of foam. I'll link that video in the description. This year, as the pool is entering its 5th year of service, I thought I'd provide an update based on a lot of the comments and questions over the past 4 years on that original video. I'm going to describe how the foam is holding up after 4 years, how I solved a couple of small problems with this method, would I do anything differently, and then finally I'll give a science lesson on water pressure for the nerds and the curious. So here we are, 4 years on. Foam is back up again. Definitely a little worse for the wear and tear. You can see some of these edges have been chewed up. We stored all the foam over the winter underneath the steps, and I think varmints got to it. So a little bit of a bummer. I did repair one piece there, number 27. Just held the sections together with packing tape, a couple layers of packing tape. There are some minor indentations underneath where the poles rest on the foam, maybe ½ inch deep. And here we are, ready for year 5. I'm going to spread a couple bags of sand, kind of even out where the pavers are. All right, 2 bags was probably overkill. I swear last year I only did 1 bag. Felt liner, has a little bit of softness. All right, so here we are. Pool is fully up. So yeah, some of the foam has compressed a little bit. Yeah, this is probably compressed like ½ inch. The weathering has taken its toll. I mean, this stuff is not super pink anymore. It's kind of like a grayish pink. To get around here to the back where I've got my 5-inch high. This thing is 5 inches. It's probably compressed, I don't know, ½ inch. All right, so the first problem you got to solve is fine tuning all of the spots where the feet sit on the patio or the supports. A previous video I did that with a water level, but in the meantime I bought one of these things, which is a laser level. Any house that doesn't have a 3D laser level, man, you don't know what you're missing. You put your laser level out, and this is my reference point. You see that, the laser line? So that's my 0. And then you just go around. You just march around to the different spots. You see that? It's perfect. Come over here to this one. Oh. Okay, if you look here, we're about, I don't know, 1/4 inch short, something like that. Not terrible, right? Not terrible. We're back here. Can you see that? Zoom in there. Can you see? Come close. You see it's dead on. It's dead on here because I fine-tuned using these little pieces of some high-density PVC that I had. I cut them into some squares. After I installed and I noticed that it was low with the laser level, I just lifted this thing up, and I had a helper slide those 2 pieces in. You could use plywood. I mean, plywood's only going to last 1 season. Besides those 2 blocks over there on the far side, there's 1 more block I put over here. That was it. Year after year, this support structure installs pretty repeatably. I mean, I make sure that it goes pretty much where it is, but when the foam compresses, you solve it if needed using that. So right now I'm plus or minus 1/4 inch all the way around. That's the main problem you got to solve. Another problem that I solved was debris and dirt, falling in from the trees. And the way that I solved that is by getting one of these battery powered vacuums that goes on the end of a pole. So I saw another tip from a guy on YouTube. He gets a whirlpool going. So I take just regular pool maintenance. I get this going. It's a nice whirlpool going. What that does is that focuses all of the debris into a pile in the middle of the pool, and then you just use the vacuum to just suck up that little pile in the middle. Real quick, real easy. So that's a good way to handle debris, because that skimmer over there is not particularly powerful. Yeah, I would do 2 things differently. Number 1, the corners of the foam pieces, I would cover them with the packing tape. They definitely are a little prone to getting damaged just due to handling and storage and this and that. Put a layer of packing tape along that beveled edge. That would go a long way towards making it more durable. The second thing that I would do differently is I would try to find some way to mark the center of the pool. That would make it a lot easier when you go to install. When you you'll see if you ever try to put one of these things up. You don't really, the liner, you could put the pool up and the frame up, and the liner, before you fill it with water, it can be pushed to one side or the other, and you can't really see it. So I would try to probably find some way to make a big, you know, ad hoc compass and mark the center, right? Using some, like, was it second grade geometry? What grade do you do geometry in? Where you put compasses, you find the center of a circle, right? Basically, I would do that with the pool, and then I would probably hang a fiducial and just make sure. Because honestly, if that liner is one way or the other, you can't see it when you're installing. Once water starts filling, that liner is not going to move. So if you have it shifted one way, it's going to be a lot higher on one side and lower on the other. That's going to cause the whole pool to kind of be a little wonky, and that's probably why you have to do fine tuning. If you could start off by getting the center of the liner as close to the center of the frame,
you're going to be better off.
All right, this part is for the nerds. I got a lot of comments that say, oh, you're going to crush the foam, that there's no way the foam can handle all that weight. Let's talk some rough math. This is a 12-inch diameter, 30-inch high pool. If you Google it, or if you do the calculations yourself, you'll find out that this is about 1,700 gallons, and it weighs about 16,000 pounds. Oh my gosh, 16,000 pounds, right? What does your car weigh? 4,000 pounds? If you drive a truck, 6,000 pounds? Ooh, this is like parking 3 big trucks right here. Well, that's a lot of force, but force does not equal pressure. Force and pressure are two different things. The pressure is almost nothing. In fact, let's think about it. This is the reason why water cannot support shear stress. The only force that is experienced by something on the ground is the column of water directly above it. So consider, as a thought experiment, 1 square inch of the ground right there. It doesn't care that there's a pool all around it. It would have the same force on that 1 square inch if it was under a pool that was 30 inches high, or if it was just under a column of water. If you could suspend water in air 30 inches high. How much does 30 cubic inches of water, remember this, that'd be 1 inch down and 30 inches up. How much does 30 cubic inches of water weigh? It weighs a pound. Look, do the calculation. It weighs 1 pound. So you're talking about 1 PSI, 1 pound per square inch of pressure, okay? Let's look at what is the rating of these foams, this insulation foam that exists. The pressure rating on this stuff, minimum 50 PSI. It's probably more like 30, 40, 50, 60. In other words, it doesn't care about 1 PSI. That's why the foam that's underneath the pool, it survives. You just saw, I'm going into year 5 of service here. And that foam, it survives perfectly. The one spot where the foam did compress underneath a couple of those feet, it's because the water pressure near the wall does require, the shape of the wall actually results in some downward force that just due to the shape of the pool. The pool actually has underneath that little cup shape underneath at the bottom, where the bottom is, pulls down this membrane, and it's reacted up here. Again, it compresses the foam. I calculated it out to be about 50 PSI. It doesn't kill the foam, it does compress it, but again, it only compressed it about a ½ inch. And I've already shown you how I solved that.